let's do something with springs, because we haven't, and I feel like the spring has been neglected. So let's think. Let's see, maybe this question, what I want to know is, let's see, how far will the spring compress? Will the spring compress? Cool. So this thing here is up on top of some hill, height h, and it's going to slide down and hit the spring. So let's think this through. At here, what energy do I have? See, I have just potential, so mgh. Right here, what energy do I have? At this particular snapshot in time, I have kinetic energy. Once I smush this some amount, and that's exaggerating, I should do that in 2 different colors. Once I smush it some amount, this means that I've compressed it to such a point that it's not moving anymore. So all of this kinetic energy has gone into compressing the spring. So at this point in time, I have 1/2 kx squared. So I can look at this in different ways. I can look at it and say, okay, so my mgh is going to go into kinetic energy, so I can figure that out first. And then I can say, okay, so my next snapshot in time is that kinetic energy is going to go into the spring potential. I can do that. I certainly can. But recognize that this quantity and this quantity, they're exactly the same. So what's happening is all of my potential from this height is going into compressing that spring. So what I actually have is a picture that looks like this. My potential energy is going to equal my 1/2 kx squared. Oh, look at that. So then if I want to know how much it's going to compress, then I'd have like 2 mgh divided by the spring constant. Take the square root of all of that. That gives me how much it compresses. That's it. So for as afraid as everybody gets of springs, they're like this terrifying thing, there's nothing to worry about. In fact, one of the things we could do afterwards is we could say, okay, there's friction. Oh, yeah, there's friction. And if I'm really mean, I'll have like the whole bottom of the hill is friction for some distance. And then you can figure out how far it compresses. Oh, we can add that in. So I think I'll do that one as another example after we do rotational energy. Because other than that, I think I've covered everything in terms of energy that we can do. So we've gone in circles upside down. We figured out minimum velocities. We figured out how far a spring will compress just sliding down. And there's one last thing, actually, I want to make sure we're clear on. And hint, hint, you'll probably see a quiz question on this to make sure that you understand it. Is that if I have something like this, slide like that, or if I have, and we'll make it the same height, I have another hill that goes like that, and a long slide like that. And the favorite question here is, which one of these slides has you going faster? Actually, let me make it a little more pronounced. I'm going to say that this one here, there we go, that this height here is the exact same as this height here. Pause. Which one is going to have you going faster without friction? So without friction, if these two heights are the same, it doesn't matter how long the slide is. I'm going to get down at the exact same speed. My velocity at the bottom is the exact same. How would that change if there was friction on the slide? So both of these have friction. How would that change? Because this one, I feel like the work due to friction is like this longer surface, no? In fact, my displacement would be in the direction of the slide. So I feel like this is going to slow me down more, that my velocity at the bottom of this one is going to be lower than this one with friction. Without, It's just the height. It's the same. Somebody might get down there. Nope. Going to get down there at the same rate. That's it. We'll add in some more fun examples here at the next one.